Good morning. Good morning. We're glad to have you here today. We've got a lot of amazing speakers. We have a lot of amazing presentations for you to see. And the reality is that the time has never been more important. The opportunities that STEM fields provide are exceptional. The need for America is profound. We are greatly excited to see all these people here, for you to come and enjoy this, to be able to see different opportunities and different things that are available to do within the STEM fields. I encourage you to spend as much time as you wish, talk to everyone. You're going to see lots of students, professionals, and educators as well. Welcome. We're glad to have you with us.
And now, let's get to the exciting part, our first panel. It's my great pleasure to introduce the moderator for today's discussion, Ed Swallow, Vice President of Verios, a division of the Aerospace Corporation. Swallow joined the organization in May 2015 and directs all civil and commercial businesses, including holding responsibility for contracts over $80 million annually with key customers such as NASA and NOAA. Swallow is also a STEM education leader. For the past 10 years has served as chairman of the STEM Workforce Division of the National Defense Industrial Association, NDIA. Ed is also chairman of our Washington Exec STEM Council and has played a critical role in the success of all three of our K-12 STEM symposiums. Ed will moderate this morning's first panel, STEM Workforce Needs and Solutions. Ed? Thank you.
Thank you very much, and good morning, everybody. Okay, Bryn, take a note. Next year, we need a coffee concession in the back of the room. Let's try it once again. Good morning, everybody. Good morning. Thank you very much. Okay, our first panel today, Bryn already told you a little bit about the folks that are going to be up here, but I'd like to invite Eric Shearling, the director of the space group at Vencore, and Tina Harrington, the director of the Signals Intelligence Program Office at the National Reconnaissance Office. And let me give them some microphones. And so I could stand up here and read their bios to you, in which case that need for that coffee stand in the back would really be required. So rather than doing that, I'm just going to start with my first question. You were born, something interested you in STEM, you're sitting here today. Fill in the gap.
All right, so mine actually started in 5th grade. That was the first time that kind of math and science was broken apart from English and history. English and history is very important, but I found it a little boring. I found it, if I could memorize it, I could pass it. Math provided a lot of challenges. You had to go think differently. You had to go solve problems. You couldn't just memorize an equation and all of a sudden magic occurred. So it started early in 5th grade for me. My next really big moment was in high school. I had the same math teacher for 4 years through high school. He was actually in my senior year voted, and I forget, the top educator for the nation that year. And he was absolutely phenomenal. And he had basically, throughout my high school career, encouraged, he never treated, hey, you shouldn't be doing this, you shouldn't be doing that. He always encouraged every single one of us to push it as far as we could. Folks that said, no, you shouldn't go take the advanced placement area, no, you shouldn't go do that. He was never that type of person. When I came out of high school, really didn't know what I wanted to do. Because at that time, I thought, with math, you can be a teacher. And for those that do know me, you know I would never, ever make a good teacher. That little patience thing doesn't exist for me, and that's like a key thing for a good teacher. And then the other thing I knew about was being what's called an actuary, which is a very important job. Both of those are, but that would also have bored me to death. So I went into college thinking I have no idea what I'm going to do, went into general education. My first summer home, my next door neighbor worked for a company called the Aerospace Corporation. And so she came over and said, you know, what are you doing for the summer? And I was like, I'm a college student. I'm going to have fun this summer. I was living in Los Angeles, about a mile from the beach. So, of course, all I was interested in doing was having fun that summer. And she said, well, you know, I work at Aerospace Corporation. We hire summer interns. Would you be interested, and do you have a good GPA? So I had just finished my freshman year. I actually had a 4.0. So I said, yeah, I do. And So she put my name in, and I got hired into the Aerospace Corporation. So this is when it really kind of now started to gel, that there was something you could do with math other than teaching or actuary. So I went and started working at Aerospace, and as I was working that summer for them, they said, you know, we actually have a capability that allows you to work for us 20% of the time, and we'll pay for your college education. So that was a great deal. So I started working for them, and the very first thing I did was go work on a little program called GPS. Pretty sure some folks in here have probably used it. Some of your parents probably used it to get you here today. I know I did. But at that time, GPS was new. We didn't know what it was going to be. Its purpose in life was basically to do military applications. And one of the very first things I worked on was, hey, can we use this for doing navigation of satellites? Not GPS, but other satellites. No one had really looked at that yet. No one had said, can I do that? Can I actually use a satellite to navigate another satellite? So we went off, and I got the great privilege, I was still in college, to go off and work with a team of folks up at Lockheed, a team of folks across the government, to actually do the first satellite that actually used GPS navigation. When that happened, I was like, yeah, math is it for me. I was all in, because that was just, you're using something that was meant for one purpose to do something totally different. And you got to go solve a problem. That's something that, you know, every day I walk in, I don't know what problem I'm going to hit that day, but every day I use math to solve that problem. And it has been the best experience. I don't think there's a day I walk into work. There's a lot of days I walk home from work very tired because it's been long days, but there's never a day I walk home from work that I don't think, God, I'm really glad I do the job I do and that I got the degree I did. So.
Thank you.
I'd have to say that I was lucky to be born into a family with a mother and a father with both an engineering background. But I think my real inspiration came from my grandfather, who owned a machine shop up in Scranton, Pennsylvania. And in the summer times, my parents, I think trying to kind of get rid of us, would send us up, and for 2 or 3 weeks, I would root around my grandfather's machine shop. They had lathes and arc welding, and he installed boilers. And I think that's where the real appreciation for engineering came. It was probably an every year dialogue that occurred between my grandfather and I at Thanksgiving dinner. He would pull out the napkin holder and he'd put it down and he'd go, Eric, if you had to take a flange and put 5 bolt circles around it, how would you figure that out? And I'm like, what do you mean? And it was a nonstop question that he asked year after year. And I never really understood what he was getting at, the inability to measure around the circumference. But when you're actually in the shop, needing to be able to measure with a straight ruler from where you want to drill one hole to the other. And I gained a profound appreciation for those engineering concepts. And it was that type of inspiration that I had that really launched me into an engineering degree. I pursued a ROTC scholarship because I wanted to become a naval officer. However, I remember very specifically the moment when I realized I could parlay my engineering degree and passion into something which I had a lot of passion for, namely an aviation degree, when I saw that they were doing selections to go and become a naval aviator. Sure enough, I was lucky enough to be selected to become a naval aviator, went through all the training and instruction. And if you've been through any of that type of, and I'm sure most of you had that type of training, it's very intense meteorology, aerospace, aerodynamics, engineering, math, and you get a lot of book work. However, you then get in the airplane and you start to have those moments where either you're flying and you see an actual shock wave as you're going through the sound barrier, or you see the sun rise twice in a given day, or those white-knuckled clenched landings that you do with an automatic carrier landing system, of which that landing you probably only see like the last second or two before you hit the deck and land. You tend to develop a very strong appreciation for science, technology, and engineering and math. From there, I was afforded the very real opportunity to then translate that into a career to support Tina and the work that she does, supporting our nation in the designing, developing some of the most complex systems that our nation develops. And the systems are great. However, working with those individuals, both on the government and the industry part, seeing not only their passion for the work that they're doing, but also their aptitude and their technical abilities is really something that I think motivates both of us and an entire industry to go to work every day.
Great, thank you very much. So let's talk a little bit about what STEM looks like in the workforce. You know, both of you are supervisors, you have a lot of people working for you. You're looking for something in the people that are there, and the theme today is opportunities in STEM. So can you help the audience understand how people can get involved and what kind of things will they be doing when they're at work in a STEM career?
So within our organization, basically every engineering discipline is required. You have to be able to do electrical engineering, because if you think about just any satellite, think about a satellite has to be able to talk to the ground. It has to receive commands from the ground. In order to do that, you actually need to understand how radio frequency propagates. You have to then understand how, once it's on board the vehicle, it can then translate through the whole vehicle and how it can send data back down to the ground. Regardless of the satellite, you've got to be able to do that. So an electrical engineer is absolutely fundamental to doing that job. The next piece is mechanical engineer. Think about it. You're going to basically put something together, and its whole purpose in life, the very first thing it's going to do is go through a controlled explosion. That's what a launch is. It's basically a big explosion underneath the satellite you built, and that's probably the scariest moment of your life, when you just hope that it gets off the ground and it gets into space. But that vehicle, when that explosion goes off, it's like, think about basically an aircraft crashing into the ground, and your vehicle needed to survive that. A mechanical engineer comes up with, how do you survive? How do you get into orbit? How do you make it through life of an orbit? Then, you know, some of the places we don't think about is like civil engineering. So for a civil engineer, we don't do anything without the buildings that we have. In order to test a satellite, you have to build all these different chambers. I talk about that going through launch and the vibration that's induced. Well, on the ground, we actually have to test those things. So you've got to go through vibe on the ground. Civil engineers come up with, how do I actually put those systems through vibe on the ground and be able to do that job? Now, as a mathematician, a lot of the engineers go, yeah, you're just a mathematician. And so, you know, but as a mathematician, you pretty much cross all of those areas. I remember early in my career, I was working with an electrical engineer, and he'd go through to show me how a receiver worked. And he'd walk through the different components, and he'd show me all the little special little designs that they use as an EE. And I went, yeah. Okay, so you add here, you divide there, you subtract there. It's like, no. That's an amplifier, that's a multiplier. No, you add, you divide, you subtract. He finally went, yeah, whatever, as long as you get the point. So all of those things translate across the whole industry. Software engineering is absolutely critical. None of these things survive if you can't talk to it through the software that exists with it. So there is no part of STEM that you can actually launch a satellite without having a person that understands that and is being part of it.
That's really a good example and a description of the type of work. And Tina actually even said it earlier. It's all about problem solving. To wake up in the morning and go to work, and yeah, there are those challenges that you know you're going to have, but it's those ones that you don't know that you're going to have that really kind of fill your day. Typically, what the engineer does on a regular basis is solves those problems, and that's what STEM is all about. One of the things that we're seeing in the workforce that we have at Vencore in supporting the government is a real shift in how the government is approaching the problems. And the way that they're approaching them is very synonymous to what we're seeing, what all of you are seeing across the disruption in your own digital life. where solutions come in very different and smaller ways. And how do you identify where those are? In order to identify what those solutions are and have access to the broadest breadth of capabilities, what's happening is those challenges are being pushed down to the lowest level to promote solutions to come up to the highest level. And what that really does is it empowers the most talented and the most innovative individuals that are out there. And that's the thing that really inspires me on a day-by-day basis, to come in to work, to see what the problems are, and to see these talented young individuals coming in and applying their STEM expertise in a way that had never been applied before. It's a very exciting time right now to see that transformation in the workforce. And it's happening really for two reasons. One reason is, one I've already alluded to, which is the change that we're seeing in technology. The second reason is the leadership that we have both on the contractor and, more importantly, the government side to promote that culture of innovation.
Oh, great, thank you. So I've gotten 2 questions in, and the audience hasn't gotten any. So start thinking of a question, because I'm going to come out in the audience, and if nobody raises their hand, I'm going to stick this microphone in your face. Anybody got a question for the panel? Yes. There we go. Let me get a microphone over here. Here you go.
What are you meant for?
What are you? I think what he was looking at is what are you looking forward to, in STEM? What's the next stage in STEM?
As I mentioned, a lot of the technologies that are currently being pursued, I think are well known. The thing that's really important that we are looking for at Vencore is those individuals that want to not only answer the difficult questions, but also ask the difficult questions. And that's not something that's taught out of a book. So to answer the question directly, what we're looking for are individuals that have the courage to be able to ask those questions, and at the same time the ability to work with others to collaborate and design and develop the most effective solution. And those are things that, are going to take advantage of those book skills and experiences that you have. But it really applies another level of expertise to achieve that best solution. I think we're seeing that across our entire agency on how we're supporting that.
I'd say, just to expand on that, when I look at it, it really is about that questioning experience. Come in. One of the things, again, some of us have been doing this for way too many years, and it's folks that are coming in that are new, that are just learning, or just out of school, that come in and go, why? Why did you do it that way? Why is that the right answer? And that's what we need. We need people coming in questioning what we're doing. We need them to have the confidence in what their knowledge base is to help us look at things differently, to change the patterns that we do, to make that next stride in the future.
Tina. It's on? No, not working. So can you hear me? Oh, there we go. So Tina, you described your start as an intern. Can you describe the type of intern programs you have for high school?
So I started as an intern with aerospace. I'm actually now with the government, but I say I know aerospace still does it, the government does it, I believe Vencore does. Across the board, we have opportunities, especially for summer hires, for folks to come in. They can basically come in, start working projects very early on. It gives them a chance to see what we're doing, where we're going. As that progresses, there's a lot of opportunities once through your bachelor's degree for coming in and then getting your master's degree through the government or through a corporation. It's a great opportunity to go and put some hands-on. Depending on where you go will depend on what you do, but it's everything from an intern that I had a few years ago We had just launched a new satellite, so he went out and was part of the initialization of the new satellite, which is something, you know, a lot of college kids never get to do. And it was, you know, he got to understand how to do orbit determination, which is a fundamental aeronautical and mathematics skills that you have to do in order to do satellites. He got to understand what an attitude control system really did on orbit. He got to understand when we actually had a major anomaly on that vehicle that you don't get to go fix it. It doesn't come back to Earth and you get to fix it and you get to send it back up again. You got to get it right on the first time. And, you know, some of those lessons you learn from your mistakes are some of the best things that helps you make a lot further progress in the future.
So it looks like you've got a up-and-coming intern sitting right next to you. So you can get his resume, give it to Ed, give it to me. And if you want to, we actually have a couple past interns that are out manning the Vencore flight simulator booth. And you can also ask them for their impressions on that.
Yeah, and I'll add, at the 1 o'clock panel today, the Associate Administrator of NASA, Donald James, will be talking about NASA internship opportunities. That's one of the main things he's going to be talking about. Next question.
Thank you both for being here. Really appreciate that. What specifically with your organizations are you doing working with, I would say, middle school girls and engaging them in a positive way for STEM?
I'll go ahead and take this one. When we finished here, what I'd like you to do is go back and talk with Takara Plotter, who's manning the Vencore booth. And what Takara did on an annual basis, she actually had an outreach. She has an outreach with a local middle school. Forgive me, but I forget the exact middle school. And in that engagement, what they do on a regular basis, they bring in about, I think it was a group of about 30 to 40 middle schoolers, bring them into the facility and show them what does Vencore do from the systems engineering, the design, the modeling, the analytics, and kind of get them to give some feedback impressions and ask questions. So we are engaged very heavily with the younger individuals, obviously here today, but it's a commitment that we make at a corporate level, and because we recognize that it is the future, not just for our company, but also for our nation. Tina?
I'd say for us, it's been less targeted just at middle school girls. We actually do a lot of outreach to the elementary schools from the NRO. We actually have folks that go out. Cub Run is a big one that we work with. We go and every year have folks go into the classroom, talk about what satellites are, do some modeling building. We have had in years past things like when we do our launches, we do patches. We've done patch contests with them to get them excited about what a satellite is. But it's been not so much targeted just middle school girls, but it's kind of been across, just trying to get folks excited about the future of space.
Yeah, and the Washington Exec STEM Council has been doing some outreach, and so through one of our member companies, MITRE, we actually have a program through the MITRE Women's Engineering Group at Langston Hughes Middle School in Reston. So that was a pathfinder for us to start expanding that. The next question is coming from down the row here.
So besides your school curriculum, what else can you do to get into a STEM program?
There's a number of things that you can do in order to expand. I'm sure, I don't know if you're a Naismith student here or a different local area school. The plethora of options that exist today are broad and diverse in order to let children engage with areas in STEM. As I mentioned earlier, one of the big challenges, or one of those skills that you'll need going forward as well, is to be able to engage with other individuals in a very constructive way. One of the things that I strongly support and encourage is for all children and middle schoolers to get engaged with structured activities. And my particular area of interest is to get involved in organized sports. And it's not because you need to know how to do a layup or catch a ball. What you need to be able to do in the area of STEM is to be able to take your idea, your innovation, and be able to make it valuable with others. One example that I would give you would be Thomas Edison, for example. In his Menlo Park, The group that he had there developed hundreds of patents. However, it wasn't until he was able to go and collaborate with investors and other infrastructure leaders outside of that park was he able to really take those and make those transformative innovations, things that we use every day. So it's that ability to be able to work with others. And it's not the layup. Instead, it's being able to develop that empathy to be able to work with others in a very collaborative fashion. So I would recommend that you get engaged in any structured activity. My go-to move is sports, but anything that you can do would be helpful in that. Tina, any experience on that?
To me, so there's a lot less opportunities when I was there, but I do agree sports. I didn't necessarily do the team sports, but but even structured activities, again, that just helps with that. But organizations like 4-H, like what through basically the Washington Exec Council that you've got here, there are a lot of places that put on these activities. Look for what they're putting out there. Look at what those opportunities are. Look at even the science fairs that are outside of your school. Look for those opportunities that push you. Look for those groups. There are a lot of groups out there whose goal is to help you build that skill set. But be well-rounded. I mean, I think that's one of the biggest things I can say, and just going back to the sports analogy, part of what has helped us move forward as an engineering group as a whole is that it's not just about being an engineer. It's about knowing how to talk to people. It's about being able to interact with other folks. You can't, there's a lot of folks that are really probably the best engineers ever that sit in a room and do it on their own. And as the Thomas as an example went, you got to have those other skill sets. You've got to be able to go to the person who's a legal person, because maybe you've got a legal question. You've got to be able to talk to them. You've got to be able to talk to someone who runs money. You've got to be able to talk to all these other type of skill sets, and you don't learn that if you stay just within an engineering field. So it's very important to also broaden that, spend some time with people of other types so that you really are getting that more well-rounded, so that when you do come in to do a STEM program and you go into an engineering type job, you're able to have that breadth and go to more than just be a very narrowed focused person.
Great, thank you very much. I got another question from over here.
Do you do Linux and Unix?
So, yes, I did. One of the going back to when I first started that program I was talking to you about, where we launched the first GPS receiver on a small sat. It was a small sat then. Nowadays, small sats are a lot smaller than small sats then. I actually did the coding for that on a Unix box on the old Sun workstations. We had just come off of the big supercomputers, the Crays. So we had just gone from Crays to Suns, and it started basically using Unix. I am a big fan of Unix and all the systems that run under it, because I think it allows you to do a lot more manipulation of the operating system underneath it. And depending on what you're trying to do with your software program, it's a much better tool set than some of the other operating systems since then. But it really kind of depends on what you're trying to do. It's probably not the best environment for non-engineers to work on.
So I've reserved the last question for myself, and then we've got some exciting things happening. So space is there's a very exciting opportunities in space right now. There's a lot happening. There's a lot going on. Can you just kind of go over a few of those things that are going on there and some of the things you see in the future that some of the budding engineers out here might be working on going into the future?
So I'll start first. I think launch is just an amazing new world. You go to a company like SpaceX. Some of you might have heard of Elon Musk. His goal is basically to get to Mars. You go there, and the folks working there all have shirts, talk about basically their Mars landing shirts. He is all about pushing that edge. How do I do launch differently than I've done in the past? How do I build? So we stopped building rocket engines here in this country a while ago. He's back to building them in the country. He's off looking at other ways to push that frontier, and basically the idea of re-landing back the vehicle that the booster, yes, I'm going, not the second stage, the booster, back in so that you can reuse it. So there's an area that he's pushing very hard. At the same time, over on the ULA side, there's a group, Blue Origin, that's looking at, again, what is a new way to do the rocket fires? How do I do that differently? So across the board, launch is just an exploding industry. Where we go in the future, it's going to be really exciting. It's going to be a lot more some of the commercial pushes than government pushes, and I find that really exciting because, you know, they really can go off and do things that we might not be able to do from the government side. On the other end of the business, so I talked about the launches, the other end of the business, getting to a lot smaller satellites, a lot smaller in some cases. And being able to put things up that are basically, you know, under a meter size and actually go do real mission with it. It's pretty exciting. We've actually launched some things that high school students have put together. And that's a new world for us, and allows you to do some of those things a lot quicker, a lot faster. In fact, quicker, faster is the same, and a lot cheaper, which now allows you to explore areas that you were never able to explore before.
Yeah, and that's something I'll probably speak a little bit more about. It was about 30, 40 years ago that we made our first entree into space, on-orbit assets, and since then, it's been primarily dominated by large corporations and large national interests. What's happened in the last couple years, as Tina's alluded to, is a real proliferation of capabilities and on-orbit assets. And it's a very exciting time. The mobility, the access for space is now taking that environment another order of magnitude. It's a very exciting time. Where before only those large nations or corporations could be able to do that, now people are building, companies are building these small sats in garages and launching them in multiple numbers, being able to provide their corporations and also via the web ready access to remote sensing capabilities. It is a very disruptive technology, which at the end of it is a very positive thing. It's having the individuals that understand what that technology is, what the marketplace is, and what the needs of the government and the consumers are. That's really going to drive that. It's a very exciting time right now in space. I don't know if it's quite going to be what Apollo 13 and the race to the moon was, but it is a very exciting time. I encourage everybody in here, especially if you're in between 3rd and 8th grade, to follow SpaceX, Elon Musk, Blue Horizons, Planet Labs, Skybox. These are companies that are innovating and transforming the way that we do things in space. As those things become less risky, more reliable, the government will adopt those things and make them available for government use.
Great, thank you. Now I have a question for the audience, and only people under the age of 18 can answer. What is this? Anybody got an idea? Exactly. Give that man a walking brain when he goes to the aerospace. This is what's called a 3U satellite. This is 3 times the size of the smallest satellites we're launching right now. Now, a full-size satellite is the size of a metro car. That's the big ones that we launch on the Delta IV heavy launch vehicle. We're launching these right now. This is a 3D printed model of one that was launched 2 years ago. A lot of the construction was done by summer interns in our laboratories and put it together. It has the ability to point itself, to look at the Earth, to take pictures, and to beam those pictures back down to the Earth. We're doing a lot more with them now in an even smaller form factor. You can see this and a couple of other things in the aerospace booth. But right now I've got something even more interesting, because you heard a little bit about this earlier, but right now we have Thomas Jefferson with us right now from the Washington Nationals. And for anybody out there, how you doing, Tom? And for anybody out there, he will be outside in 15 minutes, and we'll take on all comers in a race around the park, the playground. So we're looking forward to a great day today. Get out there, go find. There's more of these running around this place than just this one. So go find them and go have fun. There's a lot of hands-on activities. Looking forward to everybody staying the day and having a great time. And go chase him around the parking lot a little bit. He had way too much energy. Thank you very much. And thank you, Tina and Eric.